this is the content that we'll be covering for 6A. This last bit, radians in the unit circle, will be done in a separate video. It just takes a little bit too long to put it in all in the one video. So away we go. So the degree is a very ancient measurement. It is 1/360th of a full rotation around a point. And just like hours contain minutes and seconds, a degree contains 60 arc minutes, or minutes for short, and 1 minute contains 60 arc seconds, or just seconds for short. So the radian, which has a little symbol C at the top, which means circular measure. Maybe your CAS will use R, which possibly could be for radians, but it's actually the angle that's subtended at the centre of a circle by an arc length equal to the length of the radius of the circle. So let's have a look at that. So let me say straight up that this is not my work. This is an online program, Geogebra, if you haven't used it before, and this is the guy that created this little interactive, very clever man. Anyway, so this is going to be a circle with radius of 2, and you can see the angle being measured in there, and I'm just going to drag this point. And you can see that the arc length is getting larger and larger and larger, and in the top corner you can see that I'm just about at 1 radian there, if I can get it to sit there. And you can see that it's saying that the blue arc length, which is this curve here, is 2. The radius is 2, the arc length is 2, and so this angle in here is 1 radian. So I've gone a little bit past it, it's 1.1 radian. And 1 radian is round about 57 degrees. We'll get to that in a minute. So let's have a look at how many radians fit around the circle. So I can continue to drag that around. There's another radian, so that's 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and a little bit more. In fact, the little bit more, if I put that up straight, is 6.28 radians. Now this is rounded off, 6.28 radians is rounded off. So what I'm going to do is I'm going to pull this radius down to be 1. And let's have a look. Can we make it 1? There we go. And let's have a look when I drag this point around. 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, 6.28. It's still, you can see it's just a little bit shy of a full circle. And so for this circle here, the circumference that we've got, you know, the formula for the circumference is 2 pi r. And so our circumference for this circle is 2 pi, our radius is 1. And so our circumference is 2 pi. And if our circumference is 2 pi is 2 times 3.14 approximately. So I've rounded that off. And 2.314 is 6.28. Our circumference is 6.28, and there are 6.28 radians in a circle. And a radian measure works regardless of the size of the circle. So I'm just going to pull this back to around here. So we've got 5.29 radians shown on that circle there. And then I'm going to grab, and you can see I'm increasing the size of the radius, decreasing the size of the radius. And up in the left-hand corner, despite the fact that all of those radian arc lengths are changing, the actual angle in the middle stays exactly the same, 5.29 radians. So an exam tip is to have your CAS calculator set to measure angles in radians. Sometimes we refer to that as radian mode. But you need to know how to use the degrees symbol and the radians symbol to force the calculator to do calculations like tan of 60 degrees. There was an exam question a couple of years ago that had kids work out tan of 60 degrees. And so to do that, you need to access these two symbols on your calculator, and there's a variety of ways to do that. The pi button, the palette that pops up when you press the pi button on the TI Inspire, has both of these things here. If you're working with degrees and you need to work in degrees, minutes and seconds, you need to access those symbols. On the button near the delete button, you can see this button here, and when you press on this, another palette comes up and you'll find this box in the middle, and you can actually just put in, if you've got degrees and minutes, you can just use the degrees section and the minutes section. You don't have to put anything in this last one. And if you wanted to convert from degrees measurements into radians, you can use this button and then just put your values in and press enter, and it will automatically pop up the value in radians. Also, if you look at the little question button down in the bottom right hand corner of your TI Inspire, that also has a little palette, and you can individually select degrees, minutes or seconds symbols. So to convert between degrees and radians, we use the fact that 2 pi radians is in fact 360 degrees. If we divide them both by 2, we get the relationship that pi radians is 180 degrees. And from there, we can take this equation and we can come up with conversion factors for radians to degrees and degrees to radians. So we take the formula here. If we divide both sides by pi, we'll get to, like I've done here, you'll get 1 radian is 180 degrees over pi. And so that's your conversion factor. To go from radians to degrees, you multiply the radians by 180 on pi. If you take the same formula and divide both sides by 180, you get 1 degree is pi on 180 radians. Should have a little radian symbol there. So your conversion factor from degrees to radians is to multiply the degrees by pi on 180. Or a simpler way, if you've got radians with a pi in it and you want to turn it into degrees, what you can do is replace the pi with 180. So for example, if you've got pi on 3 radians, where that pi is, write 180 and simplify that and you'll get 60 degrees. Now the two conversion factors are very, very similar. In fact, they're just reciprocals of each other. So how do you know which one to use? Well, what you do is you multiply so that the units cancel. For example, if you wanted to do 60 degrees and you wanted to convert that to radians, you want to multiply by something that will cancel with the degree. So you actually need degrees on the bottom so that it will cancel. If you're trying to do pi on 3 radians, then you've got your radians up the top here, so you need radians down here to cancel so that you're left with degrees symbols. So this one will have radians at the bottom, and if radians at the bottom, pi at the bottom, and if pi is at the bottom, that puts 180 at the top, and then you can cancel from there. So 3 goes into 3 once, goes into 180 60 times, your pi's cancel, and you're left with 60 degrees. For the 60 degrees, you've got 60 goes into 60 once and goes into 183 times, so you're left with pi on 3 radians.